Okay, so here are some helpful, hopefully helpful files. Help files for homework 4 concerning a couple of problems that might need some explanation. So problem 1, which is actually the second one on the assignment, it's about an ice palace being melted by applying steam to it. So they give us the mass of that palace is 4.910 to the 6th kilograms. Initially it's at 0 degrees Celsius and they apply steam at 100 degrees Celsius. And the question is, how much steam do we need to apply in order to melt the entire palace? So here's a palace, here's our steam. And what you need to first of all analyze is what is going to happen to each one of those. So we have very, very cold ice, very, very hot steam. So one of them is much higher in temperature and therefore in energy than the other in internal energy. So since they are at different temperatures, that energy is going to flow from a hotter object to a colder object. So from steam to the ice. And mind you, they're not asking us to figure out what's going to end up in the very, very end, because in the very, very end, we're going to end up with some kind of puddle of water at a certain temperature. All they want to know is how much steam is needed to simply just melt that ice, whatever that palace looks like. So this palace made of ice, this huge chunk of ice, which is a lot of ice if you look at the mass, 4.910 to the 6. So this Q right here, Q is coming out of steam, so steam is losing energy, and ice is gaining energy. Now what is going on with the steam? It's at 100 degrees Celsius, so therefore it's in the gaseous state. So since it's at 100 degrees, 100 degrees is the boiling point slash you can say the point at which water vapor becomes liquid, so liquefying point. So since it's already at 100 degrees, any loss of energy will lead to condensation. So steam is going to turn into water. And you know that if you want to vaporize, we have to apply a certain amount of energy, and there is latent heat of vaporization that tells us exactly how much energy is needed to vaporize. In this case, since we have vapor already, vapor is going to be turning into liquid, and therefore we're going to be releasing that energy from steam. So the amount of energy that is released from steam will be exactly the amount of energy that went into ice, and ice is melting. So the Q for ice is positive because it's gaining energy, the Q for steam is negative because it's losing energy, but together they will add up to 0. And I'm just going to use the absolute values of both of those. So Q for ice is going to be latent heat of fusion times mass, and the heat of steam will be latent heat of vaporization times mass. So energy is gained by ice and lost by steam, but they are equal in their magnitude. So I'm going to just set them equal to each other and then just go ahead and apply. So I have 3.33 times 10 to the 5th. That is latent heat of fusion. Mass is 4.9 times 10 to the 6th. That's the mass of that ice palace. And then that is right here, 2.26 10 to the 6th. That's latent heat of vaporization. And then mass is the mass of steam that we need to melt this ice, huge chunk of ice. And so if I just rearrange these and take this, that would become my numerator, and then this will become my denominator, and I divide one by the other, and I end up with 7.22 10 to the 5th kilograms. If you use 3.3, you are going to end up with a little different answer, but it will still be the same. As long as you're doing the physics correctly, you're fine.